Hey everyone, my name is Cesar Guayara and I'm a senior gameplay programmer at Teravision Games, and on this training I'll show you how to quickly create gameplay mechanics using the gameplay ability system plugin. So, what is the gameplay ability system? It is a plugin that comes with Unreal Engine, and it will easily allow you to create gameplay abilities and attributes for your gameplay mechanics. It is thought to be networking first. That means whenever you're thinking of multiplayer games like a MOBA title or RPGs or something like that, it is super easy to implement and efficiently network your gameplay abilities. But it works for any sort of game like shooters, RTS, or something like that. It doesn't matter actually. And on this training, I'll show you a simple ability that is the sprint ability. Like if you press the input, the sprinting input, you'll your character will speed up, but if you release it, your character will slow down, and you'll have like this attribute management where if your stamina goes to zero, then your ability got cancelled and you'll slow down automatically, or even if you want, you we can create that it got to an exhausted state, so it can run for any amount of seconds. And yeah, that's the gameplay system. If you want to learn more, here is the gameplay system documentation page inside the Unreal Engine page. And also there's this GitHub repository called Gas Documentation that is from Tranic, but it has lots of contributors. If you go to the table of contents, you'll see that it explains every single concept inside the gameplay ability system component on the plugin. Also, it got a section for commonly implemented abilities and effects in case you're wondering what you can do with it. There's a part for documentation, for optimizations, for troubleshooting, and the changelog. In case you know, like this plugin come back from 420, but it's being upgraded from on this documentation from 424, and every time the plugin updates and the engine upgrades, it is it is registered in here. So let's start working on this. For you to quickly install the gameplay identity system in your project, you only have to enable the gameplay identities plugin and add this couple mode names stored on your build.cs file. So let's go ahead and do that. If you go to the plugin section, gameplay, I think it should appear, yeah, first on the list. We enable it and then restart the engine. Meanwhile, we can go ahead and copy these model names and go to our text editor, look for the build.cs file, and yeah, thank you, Unreal. Then we paste them here, take out this and add a comma on the back of the declaration, and there is we have correctly installed the gameplay abilities. If you want to confirm that, let's first compile the editor again. Wait a little bit. If you want to know if the plugin was successfully installed, you'll be able to create gameplay abilities blueprints. So yeah, I'll show you in a sec for how to check that. And also you'll get the gameplay game. I think in the gameplay section, if I'm not right, if you press right click on your content browser, you'll see that now you'll have the gameplay section and you'll have the gameplay ability blueprint. We're not going to use this actually because we're going to create our own class. But yeah, if you follow these steps, you'll easily install the plugin on your project. It can be installed on any kind of project at any part of your development process. On Teravision, we have project where we have installed on at the start of the project and on the right on the middle of the project to optimize stuff and get things done better for networking projects. Now, with our plugin installed, we could go ahead and create our classes, right? But first of all, we need to understand how does the gameplay identity system work. So for that, we could go to our documentation and read the concept section. But just for quickly reminder, the ability system component is that component that allows every actor to use the gameplay identity system features. The attributes are our resources, like I said before, for example, our stamina, and those attributes will be defined on the attribute set. Our gameplay effects are the way that we apply status effects onto our actors that use the ability system component, for example, exhausted or running or something like that. And also, those will be these effects will be the way that we can update our attribute sets or our attributes themselves. And we have the gameplay abilities that, like I said before, are the gameplay mechanics that allows us to use everything that we're using on the gameplay ability system. Finally, we could talk about the gameplay cues. These are like the classes that help us use visual effects and sound effects on our project and our gameplay abilities stuff. So yeah, I think that that should be all. Super quickly, super neat. Then we could start creating our classes. First, we'll start creating our attribute class, our attribute set, so that we can start defining our attributes and our resources. So if we look for attribute, we'll find attribute set. We'll call it the attribute set. We'll choose a folder for it. Maybe gameplay abilities. And let's set it on to public. And yeah, I think that should be it. So while it is creating our class, we could go towards our attribute set part section and go to a defining attributes section. In here you'll see every possible way to define an attribute and what you'll need. And we'll use thank you Unreal for your notification. And we'll use this macro. This macro is a macro that was created by these guys so that it is easy for us to create the accessors to our attributes. For example, the getter, the setter, and the initers. We'll use lots our getter actually. This is like the main function. The setter and the setter not that much because that's why we use the gameplay effects, and the initers it's like an alternative way for initializing our attributes. Like most of the time we'll initialize them using our uh, attribute set constructor class. Maybe other times we'll use a gameplay effect for that thing itself. And maybe other times we'll use like from our character or another actor or something like that, we'll use the init function, like if what rank is over here, yeah, init help, for example. It's automatically created. In our case, we'll use the stamina, so we'll have get stamina, set stamina, and init stamina. But yeah, we can go ahead and start working on our attributes. So let's go ahead and copy this macro, show you on top of the class definition. Let's tap a little bit out. Yep. Okay, so after that, let's create our class constructor. And then under the protected field, let's create our attributes. All of them will be your properties because we'll be using the replication property replication functions. So let's create a blueprint read only under a category. Will be a stamina category, and we'll create two attributes: the max stamina and the stamina itself. One will be the max of the value, and the other one will be the current one. So let's create first the max stamina. So on rep max stamina, come on, and f gameplay data, f gameplay attribute data. That's it. That's the type of our attribute. So max health, max health, come on, max stamina, and we'll go ahead and use our macro. So it will be attribute accessories macro. It will need our class name and our property name, and there it is. So I think here is saying that we don't have our onWrap function yet, so let's create it a little bit down. It will be a U function, and it will be void onRep max stamina, and inside it we'll have our old value. If gameplay attribute data, old max stamina. And in here, I think it will say we need an addition include. Yep. So in here, after the attribute set, we can include our auxiliary system component. And there we go. So there we go with the definition of our max stamina attribute. We can go ahead and duplicate actually all of these lines and change the names. So we can create our stamina property attribute respective accessor, and the same with our onRep function. So instead of max stamina, it will be stamina, and instead of all max stamina, it will be stamina. Okay, that's it. So let's create now our definitions of our function. Lastly, our onRep stamina. So like I said before, as this is a simple project, like a training project, we'll go and initialize our attributes in here. So max stamina. You can initialize them using the function or simply passing by a float value. And stamina will be our max stamina. And there we go. So that both get initialized on the same way. And that's it. That's all we need to do for our attribute definition. If we go ahead on to the documentation, we'll see that inside the onRep functions, we'll need this function gameplay attribute rep notify function. This is for the gameplay identity system itself, so that it updates internally every value it has. So max stamina and all max stamina, and trigger the corresponding functions. For example, I'll show you that will use like delegate listeners for our attributes. And if we didn't use this inside our onRep functions, those delegates won't trigger at all. Or could trigger, but not correctly, I mean. So let's just use them so everything works correctly. And yeah, this is the way you can define your attributes. But what happens when we are going to check if our attributes don't go overboard and go ahead and surpass our maximum value or go below zero? Maybe we'll need some sort of way to mitigate that, right? So for that, the attribute set class provides us with this function called postGameplayEffectExecute. This works by whenever a gameplay effect is called, is executed on our attribute, on our auxiliary system component, and it is updating any kind of attribute that we are defining inside our attribute set, this will be called. And inside we can check which of the attributes was updated and how we can check if we are not going over our maximum. So for this, we're going to go ahead and get the data attribute, the data parameter, and inside there is this evaluated data value that inside of it it's this attribute value. We can compare it to our get stamina attribute. There we go, our attribute accessory is now working. And now we can go ahead and set our new stamina. So if we set the stamina and we go ahead and go fmat and clamp out, we'll say that we're going to change our get stamina from 0 to until our max stamina. So get max stamina, and there we go. There we are clamping our stamina attribute in case it goes overboard and modify something that we don't wanna, like, for that will happen, that like our UI bar will go overhead, and that's something that we don't want, right? So we're missing, if I'm not wrong, our replication. Yeah. Get lifetime replicated props, right? So we're gonna head and look for it. Lifetime replicated props. There we go. So on here we can define it. And just overwrite. We're going to generate the definition, and we're going to mark as replicated our properties, right? So do rep lifetime. We want with a condition, and we want it with a notify. So for that we're going to mark as replicated our I'm not wrong, our class will be this, our property will be the max stamina, our condition will be a cont owner only, because we only want our owner to know about our stamina. If we're on a multiplayer game, I don't think it is necessary for another actor to know about our stamina. Maybe it depends on your mechanics, but you can modify this condition to none or something like that. But we need our notify that is red notify unchanged. Whenever our value changes, we're going to rep notify it. The same goes for our stamina property, stamina attribute. And there we go. We have implemented our attribute set, if I'm not wrong. Yeah, that should be it. If we compiled it, it should be go thumbs up. Let's hope it up. Meanwhile, our next step will be to add our attribute, nice, our attribute set and our ability system component on our character. So just let's wait for our project to start, and we'll go ahead and start working on that. Great, with our editor compiled, we can go back to our text editor and open our character class. And let's work on adding our ability system component and attribute set component to our class. So first of all, let's add a for declaration for them. Class UGT attribute set. Yep, there we go. Now on the bottom of the class, let's add our protected field, and let's add a uProperty that is visible anywhere. Also blueprint read only, and let's add a category for that called components. Ability system component pointer ability system component, and the other one is, let's duplicate that line, and the other one is UGT attribute set. Let's call it attribute set, and great. We have declared our components. So now we go to our constructor, and on the bottom side of our constructor we can go ahead and uh, like initialize our components, right? So as every component we create, let's create a default subobject of type utility system component, text macro with the same name, component. Now, with the utility system component, we want it to be set replicated or set is replicated. Let's go as true, and also with a little bit of spoilers, we have we'll set our replication mode. So we have three kinds of replication modes on our gameplay ability system. First of all, the full replication mode. That means everything will be replicated, meaning gameplay effects, gameplay cues, uh, gameplay tags that comes with gameplay effects. Everything will be replicated to every client. On the minimal replication mode, only gameplay effects on a minimal will be replicated. If you want to replicate gameplay cues, you'll need to replicate them manually. And yeah, if you're working with, if you're applying them onto your local client, you'll have to replicate that manually. And on a mixed mode, that means that you'll only have to replicate your gameplay effects towards your other proxies, not to your owner. Where for single player games, it is usually recommended to use the full replication mode, so that everything is replicated. Like you won't have to deal with networking issues, so that's okay. Maybe if you're going for a multiplayer game, you could go on your player characters, go with mixed, and if you're working with AIs, maybe use a minimal replication mode, because yeah, they don't care about what's being replicated to them unless you need to, for some kind of reason. And finally, let's initialize our attribute set. So once again, we create our default suit object of type UV attribute set, text macro attribute set, and it's done. Okay, there we go. We have initialized our attribute set and our ID system component. We just now need to get our possessed by function from our pawn. Find it, possessed by, let's go. Why? Because when we are possessed by a controller, it's the perfect place for you to initialize everything uh, gameplay ability system wise. So when we override this function, let's generate it. Nice. So in here we can check if it's valid our valid, never know, only is valid. Great. Our ability system component, and if our attribute set is also valid. If both of them are valid, then we can go ahead and say ability system component init actor info. What is the ability actor info? Is a certain amount of properties that should be initialized whenever you run abilities. Like for example, on the ability system component, we have this concept of avatar actor and owner actor when you activate abilities. That means the owner actor is the one that is owning the ability, but the avatar actor is the one that you are running the ability from. So in this case, the owner actor and the avatar actor are both the character class, but if you're creating a multiplayer game, it is recommended that you move your ability system component and attribute set initialization towards the player state class, and in that case, the owner actor will be the player state class, and the avatar actor will be the character class. And that way it could be quote unquote optimized, and everything will be correctly initialized. So let's add this and this. Now, what else could we add on the possessed by function? In here, we could go ahead and add our gameplay abilities, our starting gameplay effects. For example, if you want to create a gameplay effect from the start, make the character to regenerate passively stamina, you could go ahead and do that. And that's what we're going to do. But for doing that, we'll need first our gameplay ability class, because we need to initialize our ability input ID so that whenever we press an input on our project, uh, this input will be connected to our ability system component, and that will make a certain gameplay ability activate through the input ID. So let's go to our editor and create our next class, which will be, like I said, a gameplay ability. Call it GT gameplay ability. We can go ahead and on the gameplay abilities folder, select it and create class. And let's wait for our class to be created. Now, with our class created, we can go ahead and create an ability input ID for our gameplay abilities. That means you can identify your gameplay abilities inside our ability system component via a certain enumerator ID. Uh, and that works the following way. We'll need a class or a file that is like global to our project, and that usually is our header file that's the same name as our project. On my case, the gastraining.h. And in here, we'll create an enum class. So we'll create a enum that is an enum class. Let's call it EGT ability input, no, ability ID, ability input, let's call it. That extends from uint 8. And in here, we'll add the values that we need for identifying our abilities. First of all, we'll always need our none, because maybe you don't want to identify an ability with some value. Then we'll need to create our confirm value, because this is commonly used for our confirm targeting system inside the gameplay ability system that we're not going to use on this training, but it requires to be added, right? And as the confirm value is added, we need also our cancel value that also works for the targeting system, but yeah, we're going to use it. I'll show you why we need both of them. And finally, we can start adding our IDs for our inputs of our abilities. For example, if you want you to identify your ability with a certain value and a specific value, for example, our sprint ability, we can use it to identify the input or identify it with only the ability. Let me show you what I meant. So if we create here on the ability gameplay ability class, we can go ahead on a protected field, set up a GT gameplay ability input, and set up our ability uh, ability input ID, and also we could create our ability input, our ability ID, I mean. So what's the difference between both of them? The ability input ID is the ID that you'll give to the input inside our project so that whenever you press the input and our project registers that the input was pressed, the ability system component will go ahead and identify it inside itself and call this gameplay ability. But maybe you don't want to identify it with a certain input. Then you can go ahead and identify it with a certain ID. So if you want to call a specific ability with a specific ID, you can set up this and call it from its ID. Usually, both of these IDs will go with the same value. For example, if the input ID is none, this will be none, and if this is a sprint, this will be sprint. But you can go ahead and explore and try new ways to link this. Maybe you'll find something that we don't know yet. But yeah, that will be all on our ability input and gameplay ability class. Just for setting our initialized value of this, we can go ahead and add our gameplay ability constructor. And in here, we'll just another breakpoint. Thank you. Come on, generate. Thank you. Okay, and we'll just say ability input ID is equal to none. Oh, come on, none. And also our ability ID is equal to UGT none. Just for initialization sake. And now we can go back to our character class and add couple for declarations. So we already got our gameplay ability class, so we can for declare it, and also we can for declare our gameplay effect class. We're not going to create our custom implementation of the gameplay effect class because there's nothing like beginner experience wise that we need for the gameplay effect. Maybe on more advanced projects we could do it, but for now we won't. And yeah, let's leave it like that. So with that with that for declared, we can add a couple arrays. One for the subclass of gameplay UGT gameplay ability. Let's go. And we'll call it initial gameplay abilities. And let's do that as well for our gameplay effects. Subclass of U gameplay effect. Initial gameplay. So, why are we creating this? Because we want, like I said before, on our possessed by function, we want to initialize the gameplay abilities and gameplay effects that we're going to add to our character before you can play with your character, right? Now we can create these couple functions. Let's say add character abilities or initial character abilities. And it's a void function, of course. And let's do the same with the gameplay effects. Initial let's do implementation for those functions. And we could add couple properties more. Something like this doesn't need to be a U property, so let's add orientate be where character abilities given, and another one be where character effects given, because we only want to give give the character abilities and gameplay effects once. For example, uh, if maybe, I don't know, you respawn on another character, we don't want to give the gameplay abilities more than once. So in there, the ID system could maybe not know which ability to call, or maybe if you are regenerating stamina on one character, you could start regenerating twice as fast the stamina, and that won't be good for the game, right? So let's set our per character abilities given a initialized value. Great. After this, I think that we're good to go to start adding our character abilities, our character effects. Oh, we need an additional function that will be setup abilities inputs. This will be a function. This function will be in charge of setting up our player input component and link it to our ability system component. And yeah, I think that we can go ahead and start working on this. And for that, let's start adding our character abilities. So, first of all, we'll want to check if is valid our ability system component, right? Our ability system component is not valid, or uh, our character abilities were already given, then let's return the function and not don't do anything. But if we go ahead and continue, we're going to first iterate over our initial character abilities uh, abilities array, right? So the subclass of utility, let's call it current gameplay ability class on our spell gameplay ability and initial gameplay abilities. Great. Let's check if it's actually valid, that that value, in case we added some sort of null pointer or something like that. And then we can create our, but for adding our gameplay abilities, we can work with default objects of the pointers, because we don't need some sort of a specific information. So we can go ahead and create our gameplay ability pointer, call it current ability, uh, current ability. Let's call it like that. And to our current gameplay ability class, let's get default object of the class ability. If that's valid, we can go ahead and create an struct that is called gameplay ability spec. We'll call it ability spec, and inside we'll set up our default object, like I said before. We'll set up an ability input ID. No, never mind. A level. So in the gameplay ability system, you can set up levels for your stuff. For example, like if your fireball is level 1, then the level 2 can do more damage or spend less mana or something like that. For this training, we won't do anything of that. We'll just set that everything is on level 1. and that's it. Because yeah, we don't really need that right now. Now let's set up our ability input. That's where I told you that we were going to need the input that we set up on the gameplay ability class. So let's do an static cast for this of int 32 because we created an enum of uint 8 because we didn't need anything else about that. So let's just say that our default, uh, never mind, our current ability. Let's get our ability input ID. Oh, freak, I set up those things on the protected field. We could set them to public so we can access them from here. Ability, yep, there we go, ability input ID. And finally, after all of that, we can set the source object that will be this class. And with that, we have created our ability spec. After creating our ability spec, we can tell our ability system component, hey, give this ability that we just created, this ability spec that we just created, to yourself, and there we go. That's the way that you're adding your gameplay abilities. After this cycle, we can just go ahead and where character ability is given and set that to true. And that's that. Now, let's set up the same thing for our character gameplay effects. So, just as before, if our ability system component is not initialized, or if okay, our if our character effects were already given, then let's return the function and don't do anything. Sorry about that. And now let's create first of all our context. Whenever you're going to apply a gameplay effect towards a character or an actor that uses an ability system component, you'll need to create a couple things. First of all, the context that will have the gameplay effect. Then you'll have to create an spec handle that will be like the way that an object, a gameplay effect object will be created with certain information. Maybe in the future you'll see that you can set some values on runtime. Not you don't need to set every value from the attribute set or from something else. You can set dynamically values, and for that you'll need the spec handle so that you can do something called set attribute by color or set value by color, and yeah, you can update that kind of stuff. But for now, let's set up our gameplay effect context. Gameplay effect context handle, and that will be created only telling the ability system component, hey, make an effect context. On this context, we can say like the add source, the source object for that will be this class, so that the effect receiver knows like that we are the ones that are applying that gameplay effect. Maybe in your logic you can check that and say, hey, if I apply this myself, then it is okay. If another one applied, another character or another system applied this effect to me, do something else, or maybe don't accept it, or something like that. Now, as we did with our character abilities array, we can iterate over it. So the subclass of view gameplay effect that is called current gameplay effect class, or our initial gameplay effects array, and inside it, just like we did before, current gameplay effect class, we're going to check if it is valid actually. avoid null pointers. It's always good. And like I said before, let's create an spec handle from our character effect class. So let's say gameplay effect spec handle uh, current effect spec handle, and it is equals to the ability system component make outgoing spec. Oh no, make outgoing spec, and for that we'll need the class of our gameplay effect, our gameplay effect class. We'll need also the level. Like I said before, we are working only with level 1 things in here, so it's okay. And our context that we just created. So effect context handle. And there we go. Uh, if like I said, like I told you, if you do something like this, you can set on the data, and you can start creating some sort of stuff with that. But there's a property in here to check if it is actually valid, this handle. For example, spec, no, print spec handle, but is valid. There we go. And inside here we could create an f active gameplay effect handle. Gameplay effect handle. There we go. This handle is whenever you want to, for example, save this ability, this gameplay effect handle. If you applied it, I don't know, maybe you are currently stunned and you save this handle. Maybe instead of only telling your ability system component, hey, remove every gameplay effect that uses this tag, you can use this specific spec active gameplay effect handle, and it's actually faster than telling that use everything that or remove everything. So active gameplay effect handle will be equals to our ability system component apply gameplay effect spec to target. So for that we'll need our current effect spec handle dot data dot get, right? We'll need a pointer before everything of this. After that we'll need our ability system component or the target ability system component. This will be ourself again, and there we go. Only adding those couple stuff, you can set up this. You could save this or not. We could this for our training. This will be a dead variable. This will just to show you what you can do with this. Now I can remove it and nothing else would happen. And finally, after the iteration and applying every character effect, we can set up our value of the character effects given true. And that's done. Okie dokie. With that done, we have set up our character abilities, our character effects, and we only need to set up our abilities inputs, right? So for that, we want to check. I forgot to set up another value in here. Let's set up our uint inputs bound. If we have bound our inputs on the ability system way, then we don't want to set up them again, just to avoid corruption or something like that. Maybe you change your inputs and now you're setting them up again and everything will be bad if you do that. So if once again, if our ability system component is not valid, or our input component is not valid, or we already bound our inputs. How did we call that variable? Be input bound. That's it. Then we'll go ahead and return this function, and we can go ahead and continue. So this is pretty easy, but has a lot of parameters and can be easily confused very quickly. So we'll only need to tell our ability system component to bind ability activation to input component. So what goes inside of here? Side, it comes our input component, and also it comes an struct called fGameplay ability gameplay ability input binds structure that to initialize it will need these values. First of all, we need the string for our confirm target command. Like I told you before, in here that will be only confirm. So let's call it confirm here. Now we'll need our cancel. Like we did before, it's called cancel. Now we need the name of our enum that we're using to set up our inputs IDs. So we can copy this out, come back inside a string and set it up. And finally, we need our confirm input IDs and our cancel input IDs. So like you can see, once again, it is a int32 value, but we are using uint8, so we'll need to static cast it to int32, and we'll say input confirm. Oh no, that's cancel. Confirm. There we go. And do exactly the same for the cancel one, and that's done. With that done, we have bound our ability inputs to the player input component, and we only need to set up our inputs bound value to true. And great, we have set up our inputs, we have added our character effects, we have added our character abilities. We just not need to add all of these to our functions so that they are used, right? So on the setup player input component, we can add, I don't think it's add, how did we call that function? Setup abilities input. Now, on the possess by, we after setting up our ability actor info or before, it doesn't matter. Actually, let's do it after. We can add our initial character abilities and add our initial character effects. And that being done, we are ready to compile. Let's hope that everything compiles correctly. And if it doesn't, well, let's check what I missed. Great, and if our compilation succeeded, we can now finally start making abilities and gameplay effects. Sorry if the setup was pretty long, but it was absolutely necessary for you to understand how to set it up correctly and how to work with it. So now, just to check if everything's alright, we can go ahead and go to our third-person character blueprint. Let's wait until it opens. And let's open the full blueprint creator, and on the begin play we can first now check that we have our ability system component, and we can see all our values in here, our properties of the ability system component. If you want, maybe on the attribute test, you could add a default starting data. This is where I told you guys that you could create a data table where you could set up everything that we have done, like for example the values for your attribute set and stuff. But yeah, let's just print something on the begin play just to check if everything went all right with our attribute set initialization. So let's look for our attribute set. And with our attribute set, we could tell it get our stamina. Also, if I'm not wrong, we can get the same value for an ability system component and get attribute. Get float attribute for our ability system component. We can do both of them. Usually we can do this one the most because it is like specific. We can print that. Let's see if we go ahead and play. There we go, 100 on the top left corner. Let's see if what happens if we break this value. Oh, okay, same thing. Let's do the current value. Great, 100, also great. Okay, with everything working now, we have confirmed that everything's okay. But I think I did a little mistake. I don't see our character's abilities arrays or effects array, and that's because on the header file, where is my file? I think it closed. Yeah, I forgot to set it up as your property on the my bad. Edit defaults only, blueprint read only, and category, let's call it gameplay ability system. Same for the other array. And well, let's hold you out a little bit. We can start creating other stuff before we need to recompile it, so it's okay. Now we can create on the content folder a new folder that is called blueprints, and inside we can add a new folder that is called gameplay abilities, and inside we can create a folder that is called sprint, just for our sprint ability. So now let's create a new blueprint class that extends from the GT gameplay ability. Oh god, my spelling today is on point. So with that we can create a GA for gameplay ability sprint. When we open our sprint blueprint, we'll see some things. So first of all, we'll see that we have two events on the node editor on the event graph. We'll see the activate ability and the on-end ability. This event will trigger whenever the ability is activated via input or via everything else, and this event will be activated whenever you are canceling the ability for any reason, like you are canceling it, you are ending it inside the using the end ability node or end ability function or something like that. You could also add many other functions like the can activate ability, that is a check that is done before activating the ability, the commit execute function, the activate ability for event, that is some sort of like the activate ability but from an external event, and it comes with a little bit more info. You could also get that info from inside here, but it's an additional function call. And should ability respond to event, that we're not going to use actually this function or any of this right now. Also, we'll have on the right side panel, we have the tag section. This is the way that you first identify your ability with your gameplay tag system. Uh, for example, this ability tag section is like the tags that you're going to use to identify your gameplay ability. For example, here you want to call it for, I don't know, sprint, and then if you are going to you want to cancel any other abilities, for example, in here goes the cancel abilities with tag. That means any other ability that have, I don't know, fireball. Maybe you don't want to cast your fireball while running. So if you are maybe casting your fireball and you start to run, the fireball tag should go in here. Maybe you want in the block area with tag, like I said, you want to run and cast your fireball while stood still. So if you're running, you want to block that ability as well. Uh, this activation required locked and out tags. That means the avatar actor that will try to activate the ability in the on tags. That means it should this will be applied towards the owner character while this ability is active. On the required tags, that means that the owner actor needs these tags for this ability to be activated. And the block tags means that if the owner actor have these tags, then this ability can be activated. The same goes for the source and the target required tags. This is for the targeting system. Once again, we're not going to use this. Uh, we also have an input section, and it is for the replication of the input. This is not commonly used. Actually, on the Tronic documentation that I showed you earlier, it explains that this property and couple of on the advanced section will are not commonly used, and maybe they cause a little bit more trouble than helps you whenever you're creating abilities. So try to ignore them. For example, the replication policy on the gameplay ability, you usually don't want to replicate your abilities. The instancing policy means how are you instancing the gameplay object. So when executing, you on the instance per execution means whenever you execute a gameplay ability, there will be a new object of that ability. Instance per actor means if you activated the gameplay ability once, that object will be created and it will live until the actor dies. With the per execution, the object will die after the gameplay ability ends. And if it's not instance, it will use always the default object as we did when we gave our abilities to our character. The respects remote ability activation and cancellation and the retrigger instance ability, these are usually not used at all. Once again, these are some of the properties that are usually suggested to be ignored. The next execution policy means how is your gameplay ability going to run. On single player games, you'll maybe want to use the local prediction, local only maybe. I don't know if maybe local only. Usually local only is not used. Usually you'll want to run on local predicted, server initiated or assembler only. And that means local predicted means it starts on the client, and if the system thinks that you'll need to call the server in some sort of way, then the ability will be created on the server as well. Server initiated means the gameplay ability will be created first on the server, and then if any client is needed, it will call that client, usually the owner client. And server only means the ability will only be called on the server instance. Well, this is only for networking. You don't have to worry in a single player game, so it's okay. The net security policy, usually we don't this. This is for you to not to avoid or to ignore, but this is usually not used. I haven't used it in all my time, so let's leave it like that. The cost section is the part when you use this node that is called commit ability. You'll see that you have the commit ability cooldown, and commit ability cost. So our gameplay abilities have the costs and cooldowns for everything that we're doing. For example, if your gameplay ability has or expense stamina whenever you're running, you'll want to uh, commit your cost when, on a certain amount of time, every certain amount of time. But if you want to apply the cooldown, maybe you'll want it after the, I don't know, after the ability ended. You can't apply a cooldown. And the part on the trigger section means that maybe you don't want to use the ability input ID. That I'm looking that I also forgot to add the input ID on our the U property on our input IDs. But if you don't want to use that, it's okay. Maybe you can send a gameplay event to certain actors, and on that matter you can add maybe a gameplay event, a gameplay tag, or gameplay present trigger using certain tag, and whenever that tag is added or present or something like that to your character, this ability will trigger. This is handy if you don't want to use the inputs at all or something like that. But for now, we're going to use the inputs. So while I'll recompile and add the U properties, let's at least add the ability tags in here. So we can create a new gameplay tag, and let's call it abilities dot sprint. That will be the way we identify our sprint ability with our gameplay tag system. Uh, we'll need that, and yeah, I think that's all for now. Let's go back to our gameplay ability class and add our U properties. So U property, edit defaults only, blueprint read only, and category uh, input ID maybe. The same goes for this, and let's close this up and save the changes that we did on the character class. It's okay for now. And after it has been closed, let's rerun this. Let's wait a little bit. Now we can compile it again. And let's wait for the compilation to go. It shouldn't take too long. Great. Okay. Great. Now if we open again our gameplay ability, we'll see that we have the inputs ID. So let's set that to sprint on both of them. Like I said, we want that the input ID is the same as the of the ability ID in here. And if we go to our to print third-person character, we'll see that we'll have the gameplay ability system section, and in there we have the gameplay abilities effects and abilities array. So let's add our sprint for now. And okay, we need a little thing else. So if you go to our project settings, we want to go to the input section, and on the action mappings, we want to create a new action mapping that is called sprint. Now, it's super important that this name is actually the same that you set up on this value. So let's set up this on sprint, maybe left shift or shift. Oh, we go. I was doing it too fast. Shift, shift. Oh, there we go. There we go. Okay. With our left shift, we are going to activate our gameplay ability, and for now, we'll print something only to know if it is actually working. So if we press shift, aha, there we go. There is a hello that goes in there. But if we press it again, you'll see that we are not printing hello again. So that's because when you activate the ability, you never end it. And if you never tell it to end, it will never know how to end. Maybe you'll want to end it from other part or something like that, but for now we can tell it end ability. We compile and run again. If we press the input, hello, and then again, and then again, and if you spam it, you'll see that the print will go on and on and on. So great, now we can start actually working on our sprint ability. So now, what do we want to do? So like I said before at the start of the training, we want this ability to speed up your character when you press it, and if you release it, you can you'll slow down. So for that, we can do something like uh, let's start using ability tasks. Like I said before, like this was like a core part of the gameplay ability system, and the first ability task that we're going to use is the wait input release. These wait input tasks can only be used if but if you have an ability input ID linked with your ability gameplay ability. So what is this going to do? If you press the ability and it activates, it will listen until you release it, and when you release it, it will trigger this execution pin. It's super similar to on the setup player input component on the bind action parts when you set the pressed and released uh, functions. It's actually pretty much the same, but it is using the gameplay release system interface. So now, what happens if we want to make our character faster? So before that, we can get the ability actor info that we set up earlier on the possessed by function. So if we look for ability actor, oh, I'm on caps, actor info, actor info, let's search. Okay, there we go. If you can see that we can get the actor info, and what is the actor info? We split it. There's a lot of values in here that I said before. So you'll have the owner actor, the avatar actor. It actually adds the player controller. That's why I wanted to do it on the possessed by, so it gets the player controller in case we need it. The ability system component. If we have an skeletal mesh for some reason, then we can use it. If we have an admin instance also, we can use it. The character movement component and an anime instance tag. So we can use everything in here just by using this init ability actor info. So we're going to only get our owner actor. Let's use it and let's cast it. Cast to gas training character. Let's cast it up. Maybe I recombine it? No, I can't recombine them. Then let's leave it like that. Let's add this pinning here. And if the cast is alright, then simply we can promote it to variable. It's called character reference, maybe ref for short. And if the cast fails for some reason, let's end the ability, because we can do anything else if the cast fails for any reason. Let's save that. And while the input is pressed, we can do this. Let's print a string and show you how this works. So rest, and if the input is released, so let's print release, and after that let's end the ability again. And now there's something else that I forgot to tell you. There's this test that we have to check. So if it is on false, this ability task will check against this test. So that means uh, if if it is true, then we're going to check if the input was already released. If it is false, we're going to check if it haven't been released. So let's set it out to true and play again. Press it. It says press, but it haven't showed the release button yet. If we release it, released, and you can do over and over again. And that's great because we have checked that our owner actor is actually working, and we passed through that. It's great. Maybe with this we could. Okay, what can we do? So there are a couple of implementation that we could do. For example, we could keep checking on our character movement component to up the speed a little bit, for example, or we could call a blueprint event in here. But I think what I'm think that I'm going to do is change our max walk speed in here. So let's try that out. Let's keep the pressed and get character movement. Let's set it up to validated get just in case something goes wrong. And if everything goes well, maybe set max speed, max walking speed, max walk. There we go. So the current value on it is 600. Then let's, I don't know, 1000. What happens if that happens? And on the end ability, let's use the end ability now. We can do the same with our character reference, promote to validated get. When the ability ends, we don't know if that reference is still valid, so let's validate it. And after that, we can go back and set it up to 600. Now, let's see. Oh, oh, okay. I forgot to uh, link the pins. There we go. So let's see if I press the button and I release it. Uh, okay, I think it works. Yeah, it's actually working. We could maybe, I don't know. Let's exaggerate this value, 3000. Whoa, yep. You can feel the speed now. Okay, let's go back to 1000. I think that's okay, 1000. Maybe we could, I don't know, create variables of this, just to be more organized, but leave it like that for now. We'll go ahead and do that later on. But yeah, okay, this is only the gameplay ability part, like we saw. We are now granting to our character the gameplay ability of the sprint. Now what do we need? We have to add all of this stuff about our stamina and start checking, like if we're sprinting, then let's start by applying the gameplay effect that will modify our stamina attribute. And if we run out of stamina, then let's cancel our ability and leave it like that. So now for our gameplay effect that we're going to use on expanding our stamina. So we're going to, on our same folder of the sprint ability, we're going to create a new blueprint that is called, oh wait, from the gameplay effect class. We're going to call it GE sprint. Let's close it up and open it again so we have all the values open. So we have a lot of sections on our gameplay effect class. So let me explain a little bit of everything. First of all, I think this is the most important thing on the gameplay effect class is the duration policies. So there are three. instant, infinite, and has duration. Instant means that whenever you expand or activate a gameplay effect, it will be activated, then it will be applied, and it will be removed. Infinite means that it will be created and activated, and until you tell him to, it will be removed. And has duration, it means that yeah, it will have like some sort of time of life, and after that time of life expires, then it will be removed. The modifier category is where you can add the modification for your gameplay attributes. Like I told you before, like you can modify any of your attributes, in this case max stamina and stamina. You can add them, multiply them, divide it, override them, or even invalidate them in case you don't want to use on the runtime of your game any gameplay attribute anymore. And you can add certain magnitude. You can say a specific float. Maybe you want an attribute to be in charge of that. Here you can set it up. Maybe you can create a custom calculation class of that magnitude. This will be. I don't think that we touched this right on. It is explained on the Tranex documentation page. But more or less it goes by whenever you want to set up a custom value for your gameplay effect, but maybe you need to do a little bit of more of calculations beforehand, then you can create that custom calculation class. And the set by color is maybe another way of creating a custom calculation class, but instead of creating a new class, it is on a similar on the same function that you are applying the gameplay effect. You can do those calculations and send a gameplay event with certain tag to identify the value that you want to send. And that's the modifier part. The execution is similar to our custom calculation that I told you on the modifier, but instead of only calculating the modifier, this will calculate like the way this effect will execute. Uh, yeah, that's it. The conditional gameplay effect, I don't touch this that much. I'll leave it empty because I don't know what it does. Actually, I haven't used that in a long time, so let's leave it like that. The period works more with infinite and has duration gameplay effects. It actually does it if it has some sort of time like infinite or has duration. Every, like for example, if your gameplay effect has a duration of 5 seconds, maybe you want every second to do something. So in here you'll tell him to do some sort of thing every second. The application it has to do with the chance to apply this gameplay effect to targets. If you want to have some kind of randomization on this, maybe we can add this kind of stuff. But right now not going to use it, so I'll just going to set it, collapse it. The overflow, I haven't used this like at all, so let's collapse it. The expiration, it just means that if you want to have some sort of calculation of the expiration of the gameplay effect to remove it or something like that, we're not going to use it, so let's collapse it. On the display port, it's how do you want to play with the gameplay effects so that it displays something. For example, like I told you before, we can use gameplay cues for it to use visual effects or sound effects for that, and you can set it up in here. Right now we're not going to use it, but maybe later on in the training. Let's collapse it for now. On the tag section, this is like the most important section. The gameplay effect as a tag is the way that you identify the tag, the same way that you identify it on the gameplay abilities part. So, for example, like in abilities, if you want this to be, for example, a gameplay effect for whenever you are on fire because someone hit you with a fireball, Well, you can identify the on fire effect in here, and the granted tag section is the gameplay tags that you will grant to the targets that are affected by the gameplay effect. So, for example, if you're on fire, you want him to have this gameplay tag that identifies him. So, fire will be in here. The requirements section will be like the gameplay tags that are required to continue processing the gameplay effect, or to be applied, or to be removed. And the removal gameplay effects queries are some queries that you can do to remove gameplay effects when this gameplay effect is applied. Maybe you want to remove the on fire effect when you enter the water and the water applied you this gameplay effect, or something like that. The immunity section is for whenever you want to grant immunities to gameplay effects. We're not going to use that right now, so let's collapse it. The stacking is, for example, whenever you want the on fire gameplay effect to accumulate certain amount of times. So you can set it up in here, but we're not going to use it right now, so I'm not going to expand a lot on this. And the granted abilities is in case you want to dynamically grant abilities to your characters whenever gameplay effects are applied. I'm not going to use that right now, but this is great for large scale projects or dynamic projects. And that's it. This is the way our gameplay effects work. So right now we're going to create an instant gameplay effect to show you how do you work with gameplay effects inside your gameplay abilities. So we are going to add a modifier on uh, your sprint ability, and we're going to modify our stamina, and we're going to say, okay, let's add minus 5 to our stamina when this gameplay effect is applied. We can apply these gameplay effects on many ways. For example, we can apply them in the same sort of way that we did on our character class. For example, creating effect context, spec handles, and then applying them. Or we could use the cost section that I explained to you before. So let me show you how it works on both ways. So for example, if we do this, let's do let's get our ability system component, right? Let's check that it is valid. It should be valid, but we never know. Sometimes weird stuff happens and invalidates, so always validate your stuff. And after that, let's make oh, my bad, typing very fast. Okay, so make an outgoing, oh no, make an effect context like we did before. After that, we want to make an outgoing spec of our gameplay effect. So in this case, it will be the sprint gameplay effect. And after that, we will want to apply the gameplay effect spec to target. In our case, it will be the same attribute, the same ability system component that we are using, and the spec handle will go in here. And there we go, just like that. Oh, I forgot the level. It doesn't matter that much what kind of level, unless you're working with levels inside your game. But for now, on our training, it doesn't matter. Let's leave it on 1, and let's try it out. So how do we check if our stamina is being changed? Maybe on the tick function, print. Let's get our ability system component. Let's get float attribute from ability system component, and let's get our stamina, and there we go. So let's go ahead and okay. Oh, I forgot to change the duration so it doesn't spam our screen. So if we're running and we're moving, and if we run, okay, I know what just happened. It's saying that our ability component is null because I forgot to do one additional thing, and it's my bad. So let's say continue, and let me get back to it. Meanwhile, you can see that our stamina was correctly modified to 95, but let's fix it up right now. So let's close our editor. And something that I forgot to tell you whenever you're adding the ability system component to your character is that every actor or character that has an ability system component also should extend this interface. It's called e-ability system interface. This interface only has one function, and is the get ability system component function, and it is super important because the, this this interface allows the system to identify faster which actor is or isn't an ability user or ability system component user, right? So we can implement this. Let's say alright, and let's return our ability system component right ahead. And there we go. Just with that, oh, I totally forgot, my bad. Yeah, but just with that, implementing this function will be easier for our system like we did before. If we are using our attribute accessors, it was telling us like, hey, our ability system component was null because we were trying to use this function, but our character didn't have that function, so it will be null pointer. So let let's wait for the editor to load up again. And now, once again, I think we haven't changed anything here and we saved everything. Yeah, okay, that's great. So let's play again. And if we run, we have no crashes again. That's freaking well. It wasn't actually a crash, it was a breakpoint. But it will work as expected. And you can see that every time we press our input, the stamina will go down by 5. Now, what can we do with this? We the same way that we did before, we can, instead of doing this, we could set the sprint gameplay effect as the cost of this gameplay ability, and instead of this, we'll say commit ability cost. So the same way that we did before, let's press, and you'll see that we go faster and our stamina went down on 5. And that's great. But well, this shouldn't be the way it works, like, right? If we are running, the stamina should be running as well. Like it should be uh, going down. So why are we using better the committability cost instead of applying the gameplay effect as we did the other way? Because we can do something like this. We can set up a timer in here. Set timer by event. And then setting back the timer, we can go to event, create event. Maybe in here create a custom event that is called setup cost. And let's say that every, I don't know, half a second will commit our ability cost. And the good thing about using the commit ability cost is that it actually tells us when this cost couldn't be able to be committed. So if this is not working, then we just want to end the ability. Oh, whoa, 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 whoa. My bad. And ability. There we go. We just want to end the ability and everything should be working again. So if we hold, you'll see every, whoa, only once. Okay. I forgot the looping check. My bad. Okay. Once again, let's press the input. And aha, it starts going down. You'll see that our speed is still up. after we go to 0, whoop, our speed goes down again. And that's great because it's working the way we intended, right? But we can't activate, if we try to activate the ability, it won't activate again because we are not, we doesn't have stamina, right? So why, what do we need right now? We need to regen our stamina. How do we do that? Well, with another gameplay effect, of course. So let's create another gameplay effect. GE stamina region. On the stamina region, let's close it up. Let's go and let's say it's an infinite uh, a gameplay effect, and we'll modify our let's go down here, our stamina, and let's say it goes until we'll add maybe, I don't know, like uh maybe every zero point 0.1 seconds, maybe. Don't really know if that's what we want. Maybe it's too OP, but okay, we are running again. We just created the gameplay effect, but we haven't added, so we have to go to our character class. Now that we have our initial gameplay effects array, we can add our stamina regen as well. Compile it, save it, and you'll see that it is running theoretically, but if we press the input, you'll see that our stamina goes down, but then super goes up. So what can we do to avoid that? Well, remember the ongoing tag requirements that I told you before on the gameplay effects? We can use that. So let's collapse a lot of stuff in here. And oh, okay, I forgot also to identify our gameplay effect tags and stuff. So let's go ahead and do that. On the RX section, we'll create here under sprint, I guess. Sprint, let's say spent stamina. And the same goes on here. This is the sprint gameplay effect, right? And on the stamina region, we can say in here again, maybe stamina region, and the stamina region again. So if we save this, you'll see that nothing changes. Like we are still running without problem. It's okay. Now you'll see that obviously our stamina is still being regent at a much faster pace than our expend stamina. So we can go ahead and on the ongoing tag requirements, we can go on the ignore tags. It says none of these tags may be present. That means if, for example, our spent stamina is present on our character, we won't regen any stamina, or this gameplay effect won't affect any of it. So let's use it to see that it is not working. Why it isn't working? Did I add it on the incorrect part or something like that? Let's try on the other section. Maybe I was wrong. Spent stamina. Oh, okay. Yeah, I got confused with that. My bad. So you needed to ignore the other and require the one that you needed. So that's it. So like you see, we are spending stamina, but if we stop the the gameplay effect, it will stop running at all. So what can we do about it? That's actually pretty funny how it's working, right? But no, but I don't think it should be here at all, you know. Oh, I know what's happening because this is an ignore and this is an instant. That was the problem, right? So let me see what we can do with this instead. So let's refactor our ability. So instead of applying every amount of time this stuff, and if not commit the ability, so let's do this thing now. On the ignore tags, we're going to spend the stamina. So for example, spend the stamina. There we go. So what happens, like I said before, the instant gameplay effect will apply and go away. And yeah, for the instant that it was spent, that it was set in here, of course, it will go ahead, go in and go out, and it will be like in a couple frames. So we wouldn't notice that. But if we create our gameplay effect instead of instant, we create it infinite, and we tell him to and we tell him to for example, tell him to go every zero point 0.5 seconds on a period, and we tell it to, I think the commit ability won't work in here if I'm not wrong. So let's check that out. Our ability won't be cancelled, but I think it will work as we want it. So we can go ahead and do the same thing that we did before, actually. My bad. So ability, but this is great. I can explain you guys more stuff. Ability system component, and let's once again this. Then we want to make effect context, and then make outgoing spec of our sprint gameplay effect, and then apply a gameplay effect spec to target, which will be this same target with this effect spec, and there we go. So now it should actually work. So you'll see that we're not regenerating stamina while we're running, but I forgot remove the gameplay effect, and that's why it was still spending our stamina. So now what we can is promote this variable to say sprint sprint effect handle, maybe it's righty. And after the ability has ended, we can get our character again in here. Can get our ability system component in here, and after that we can tell him to remove gameplay active gameplay effect. It will ask us for effect handle that we have right here, and there we go. So let's try that again. So if we press, we're going to spending stamina, and if we release, the stamina will regen correctly, and there we go. The sprint is actually working that we intended. So now after this, we'll have like this corner key that in case we spend all our stamina, will be still running, if I'm not wrong. Yeah, it wouldn't matter if you um, spend your stamina or not. Like it doesn't matter right now. But that can be actually changed. What we can do is the following. Instead of changing our speed in here, we're going to change our speed on the character itself, and we can set a bool variable from here telling, hey, we are running, and if we are running, then our speed will change. And then we can check with on the inside our sprint ability. Instead of doing this modifier, we can create a custom execution that calculates this value, and if our Oh no, never mind. We can create a listener. I was already thinking overboard. My bad. So let me show you how does it work. So after setting this up, okay, yeah. Let's go ahead and create our listeners of our stamina on inside our character, and let's see how we can cancel this ability. And for that, let's go towards our textator and our character class, to the part where we were adding our gameplay abilities and gameplay effects on the possessed by function, and tell our ability system component the following. We could tell him, hey, give me the gameplay attribute change delegate of the attribute set, get stamina attribute, get on get stamina attribute. Oh, I think this won't be able to because I set it up on protected. If I'm not wrong, if I set it up on public, I'm not wrong. Yeah, on of the stamina attribute, and after that we can bind it as any other delegate. So at the object will be this, and we'll need to create another function. So for example, we can create our function void on health, on stamina. What am I thinking on health? Stamina changed. And we can go ahead and set the same thing as we did on the attribute set. Const f on attribute change data, and with this function set it up, and there we go. Is there anything you need? Recognize type, view class function. Up. What? Oh, there we go. It didn't need to be enough on U function. I said it was a U function. Yeah. Okay, let's leave it like that. So after declaring that, we can go ahead and here and set up the gas training character on stamina changed, and there we go. Now with this function, we can, if we want, set up a breakpoint in here, and whenever our stamina changes for any reason, this will trigger. And now we can simply here, whenever our stamina goes to 0 for any reason, we can apply a gameplay effect that is for exhaustion maybe, and if we are exhausted, we can easily cancel this gameplay ability because we can do something like our next ability task. Wait, gameplay event. Uh, wait, gameplay event. Come on. Okay. The wait gameplay event task lets us wait for certain tag to be applied or removed or something like that on our character. So if it has this event tag, then it will trigger this event received pin. So what we can do is, hey, if we receive the event of exhaustion, we can end the ability. That way, our speed will be normalized again, and our gameplay effect will be removed from us, so we can start regenerating again stamina. And that should be it. So let's first of all let's set up in here another U property for this. Let's pipe it up until on the sprint category, subcategory, and our subclass of U gameplay effect. Oh, whoa, whoa, gameplay effect. Let's go. And exhaustion gameplay. Oh, effect class maybe. And there we go. Effect. Let's go. So, having this exhaustion effect class, we can go towards our stamina changed. And with that, we can go ahead and tell if our data, let's see what's inside our data. We have our new value and our old value. So if our new value is less or equals to 0, it is a float value if I'm not, yeah, it's a float value dot f. So if our new value is less or equals to 0, that means we're officially exhausted. Then we can go is maybe we'll separate that into a function, let's be a little bit organized. So apply exhaustion effect. Exhaustion effect. So we will just need to find that function, and if our ability system component is not valid, whoa, is valid. If our ability system component is not valid, then we can return this function because we're not doing anything without our ability system component, and then we can go ahead and do something similar to what we did in here. Can create a context handle. After that, we can create the effect spec handle, and then we'll apply it. But instead of the current gameplay effect class, it will be the exhaustion effect class. This can be const. And there we go. I think that should be it. We only need to apply the exhaustion gameplay effect in here. And done. I think this should be it, right? So let's test it out. Let's compile it, wait for it to compile, and then again can go ahead and continue working as intended. And now that our project compiled correctly, we can go ahead and start creating our gameplay effects, right, for the new exhausted state. So let's go ahead and create our new gameplay effect. Gameplay effect. We'll call it GE exhaustion. Close it up, open again. We'll tell him to be with a duration maybe. What if we have 2 seconds of not being able to run again after depleting our stamina bar, right? So now we're going to add a new gameplay tag, state exhausted. Same in here. So now when we apply this gameplay effect for 2 seconds, we're going to have this gameplay tag applied. We have to go towards our third-person character, and we have now our sprint section, and the exhaustion effect is applied. So if we play as we always do, anything should change. Should be able to go to 0 and continue running as intended, as we always do. Correctly. Now that I think of, I didn't validate this class. Okay, maybe let's wait. I'll wait for to validate it next time I compile. It has been set up, so it's not that of a problem. But remember to always validate your stuff, guys. On the ability, let's do this. So let's wait for pam 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 for gameplay tag, gameplay event. I mean, yeah. So let's wait for a gameplay event. Let's see if this triggers. So let's print it out. This state exhaustion. A ver. Let's see. Okay, it's not being triggered. So maybe we have to use another ability task. What about uh, gameplay tag add? Because we are adding this tag towards our character, right? This should trigger. Aha, there we go. There is the hello. So what we can do is replace the hello with our end ability, right? And now we're when this triggers, we are not we are exhausted officially, but we are not we're letting the character run even if he is exhausted. So what can we change about that? Remember our activation tags? We can block them. This ability is blocked if the activating actor has any of these tags, so we can block him if he's exhausted, right? So let's try that again. So if we run, and if we exhausted, aha, we got back to our speed. But well, I didn't test it out the couple seconds, right? So let's wait a second. Consider again. And if I try to run, you'll see that there. I'll spam it until it allowed me, and now we can spam it again, and then it not allowing me until there. 2 seconds. It's working. We're in an exhausted state. Now, actually, I think that our ability is complete. But you know what? Sometimes that these prints are not production friendly, so we can remove them. And also, what happens uh, with our stamina print, right? Is the same. It's not production friendly. We don't want to see that in on the top. We can look at it maybe on the bottom as a loading bar, maybe that it updates with every trick. So what we can do is actually the following. So we can create a new player controller class that we'll call GT player controller side of our public. Let's wait for it to add the new class. Come on. Well, meanwhile, oh no, never mind. We need the new class for it. I was thinking of connecting the dots, but no, let's wait for the class to actually get added to our solution. Now, that's great. So, with our class added, we can now add the following on the public section. We can add a new function that is a blueprint implementable event that we can call void pp on stamina changed, and it received a float of the current stamina. So current stamina, and also we could create maybe function blueprint implementable event void pp on exhaustion. Uh, yeah, we could work with that on exhaustion so that we can trigger the player controller to tell the UI that we're going to create, hey, we entered the exhaustion the exhaustion state. So now where are we going to use this? We are going to call them from the character, and where we are here we can say, okay, AGT player controller pointer character controller. Let's cast it out. Get controller, get components, no, get controller. There we go. And if is valid, character controller, then we're going to character controller, BP on stamina changed, our data.new value. And there we go. The same thing can be done in here after applying our gameplay effect. We can do is, instead of on stamina changed, we can go with on exhaustion. And like I said, we have to validate as well the exhaustion class. And there we go. With that, I think there's nothing else to be saved in here. We can rerun our engine and start creating our blueprints so that we have UI and connecting that with a new widget that we create, couple new widgets. So let's see. Nice, so it was pretty fast. On the blueprint section, we can create a new player controller. There we go. Player controller. Right. So with this, we can go to our world settings. We have to create a new game mode, if I'm not wrong. So game, gas training game mode, and we'll see. Third person character blueprint, which is this? Which one is it? Is this one? Let's see. Third person character. Okay, yeah, it is that one. On the player controller, we need our PP player controller. And if I override it in here, everything should be working as expected again. Yeah, we have no problem at all. So now what are we going to do? We're going to create on our maybe a new folder, a UI folder. We're going to create our widget. So there will be hot, let's call it. And on our hot, let's full screen, yeah. Okay, so let's add a progress bar onto it. This progress bar should be on the center. Let's send it down, like minus 11, 12 maybe? No, minus 11 it was, yeah. And it should be on the center. So right. And now on our player controller, we can set add widget get to viewport. How is it that function called? Viewport. Um, 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 um. Okay, create with, yep, there we go. We're going to create widget. We're going to self, right? We're going to create our hot. We're going to add to viewport. That was. Oh, but first of all, we need to check that it is actually valid. In case it is invalid, There we go. So if everything goes well, we have our progress bar on the bottom. So now we can actually, oh, wasn't. Okay, minus 12 seems like it works right now. Yeah. Now we can set it up a little bit. This to 1, maybe 300. Uh, Minus 150 to be on the center. And finally, we can bind maybe? No, we don't need to bind it right now. So what we can do is on our player controller, we can create our BP stamina changed. We can actually, it is valid. We can promote it. User hot maybe. Oh, and you check, get our user hot validated. If our user hot is valid, we can go inside and create a couple new events. So let's create a new custom event that is called update progress stamina progress. And let's see. Just to be sure, let's print this out if it is actually working. So, yep, it is working. So you'll see that sometimes for some reason, like it go to 102 and then 200. That's where it is actually getting clamped the value. So we can fix that, of course. But let me first update this value, and we can, well, and we'll fix that right away. So we can call this stamina bar. This has an input that is a float input called the new stamina. We should, we need our max stamina now that I think of. Right? So we will need to update this value now that I think of. But wait, right now we can set our stamina bar and set percentage, set percent to our stamina uh, divided by our max stamina. And if I'm not wrong, we can go ahead in here and set update stamina progress. Let's tell it that max stamina is 100, but we're going to change that out second, just in case we want to play with values of our stamina and stuff. If we run, it should update, and if we stop running, it updates faster. Yeah, it actually works pretty well. Also, if we wanted, we could we could add the exhaustion effect. So the same way we did it here, maybe let's call the exhaustion. We'll do the same here. And what we could do about this is maybe we'll create a new custom event that is called update exhaustion. And when this happens, our color, fill color and opacity, our fill color will be red, and let's delay it a couple seconds, and then we'll do it again. But with green. Let's copy this so that our bar actually looks like a stamina bar. Style, where is that? Oh, there we go. Color and opacity. There we go. It actually feels like a stamina bar. Okay, so let's see. Oh, I forgot to connect it. My bad. The exhaustion. There we go. So let's see. Run around, run around. 0. And then our bar is green again and we can run again. There we go. Well, we're on the last part of our training. We can add a little bit, a little thing extra in here. Other than obviously, let's add so that I don't miss it again. Our max stamina as well. Const float max stamina. And on this function call, we'll need our attribute set, of course, and it's valid our attribute set, please. Get max stamina. There we go. So, that being done, we have our new values on our stamina change and stuff. And we only need, we could add something else, like for example, let's take this down to minus 10, 10, 10, 9. 15 is great. So, and let's bring it up to, I don't know, maybe 600 and this minus 300. Great. So now what we can do is, now that everything is like telling us much better way to do things, maybe you could play with your values or your rates of exhausting the character, maybe recovering the stamina and stuff. What you could do and what we're going to do is when we are running, we're going to use a gameplay queue, and for that we're going to add a new visual effect to the bottom part of our toes, of our feet, like in on the Achilles tendon. We're going to add a little gameplay, a little visual effect, so that you could see like if you're running, like if you're faster than you usually aren't, right? And yeah, that should be done using the sprint section, the sprint gameplay effect under the display part. What we can do is add a gameplay queue, and that's with that. First of all, we need to create that class. Not a class per se, but a blueprint class. So let's create the gameplay queue, and we've got a couple actors to extend from. We're going to use the notify actor. That is an actor that will be spawned whenever you trigger the gameplay queue. So let's call it GC Sprint, maybe. And in here you can go to the event graph. And now you will see that we've got like a little bit of properties. For example, this gameplay queue tag. This tag will be the one that let us trigger the gameplay queue. So let's call it gameplay queue sprint. Something pretty simple. You can work it out so that it accommodates to your project, and we have many functions to override. So the first one that we're going to override is the one that is called while active. It's in here. While active means that it it will trigger every time it is active, like some sort of a tick. So what we're going to do, if my target usually is our character class. So let's cast it out to third person character. No, third person character. No, our gas training character. I meant. Yeah, uh, our gas training character should have a mesh component, right? Right. And now, where are we going to put this thing, right? So we're going to go to this visual effect. We're going to open our mesh and open our mannequin. And on the skeleton part, we're going to check for our our feet bones. So foot left, foot right. So on them, what we're going to do is uh, spawn. Let's put this right here. Let's spawn an emitter attached, and the emitter will be a property that we are going to promote to variable. Let's call it speed effects, EFX. So this speed VFX is going to be a particle that I imported from the Paragon Minion project. It's a free project that you can get yourself, and it's not that heavy. So I just imported this particle, so to not bring everything else. On the socket, we're going to tell him to be on foot underscore L. Everything should be as expected in here. We're going to save it up, and then we're going to save also this component. So we're going to speed left speed left speed bfx. Let's call it like that way, because we'll need to remove it at some sort of point, right? So let's do this once again. Our character, opa, opa, from our character, there we go. So let's get up here, and we actually can see where it is. While active, boom, and now instead of L is R, right? And let's bring it up this here, and let's variable again, and instead of left it will be right speed X. And there we go. After that we just can return it as we need it. The return value don't actually means anything at this moment because we don't need it. This is for kinds of notification inside the gameplay queue, but we don't actually will work with it, so it's okay. And then we need on the remove function. This function is the one that allows us to remove what we need to remove whenever it's needed, right? So we'll get the left speed VFX compared to validated get and destroy the component, right? And do exactly the same with the right speed uh, component and destroy exactly the same component. Uh, and there. And now if any one of these ones are not valid, let's just pass it over. Same with this one. Just in case any one of them wasn't spawned for any reason, we'll just destroy them. And there we go. There is our gameplay queue implementation for this project. What we can do is apply it on our gameplay queue gameplay queue section of the sprint gameplay effect, or we could also apply it from the gameplay ability itself. For example, just before waiting for it to be removed, we can call the add gameplay queue owner. And like I said before, you won't need an object itself. You'll need only the gameplay queue, the gameplay queue tag. But for some reason, my editor is not showing me my menus. So let me close the editor. Okay, that's give us the possibility to update our blueprint event. So it's actually good that that happens. Let's wait it a little bit. Okay, and there we go. Once again, we can open our gameplay ability and set our gameplay queue gameplay tag. And there we go. So let's try it out again. If we run, aha, you can see the gameplay effect, but there's something missing. What happened with our UI? Let's check it out again. What happened? Oh, okay. I forgot to override the. That was the map change. I thought it was something else. My bad, my bad. So again, okay, we can run. We have a gameplay queue running. If we get exhausted, let's see. Our gameplay queue should go away, and there we go. We now have a gameplay ability with everything that it should. Oh, okay. If we if we stop running, our gameplay effect, our BFX is still on. But well, we now have a project where we are adding gameplay abilities, gameplay effects, gameplay cues, and attributes, and we're working with them. We're listening to them, and that's great actually. If, just remember, if you need anything, you can go to the gas documentation uh, project page, and it will help you out in there. And yeah, there's a lot of communities for that. Also in the gas documentation page, they tell you about this Discord server called Unreal Slackers that has this uh, gameplay abilities sub channel, and you can share all your thoughts or even your mistakes or even your problems, and people will try and help you out. Sometimes I help that out, and mostly I'm asking around. So yeah, um, and stay safe, play games, and geek in. Goodbye.